Properties of trapezoids and kites. Trapezoid, what is it? It's a quadrilateral, so it has four sides with exactly what? Well, it has exactly one pair of parallel sides. Okay, so I'm gonna make a little sketch here. So usually when we think of trapezoids, they look something like this. It's not the greatest sketch, but I've got one pair of parallel sides. If it had two pairs, it would be a parallelogram and not a trapezoid. Okay. Now the two sides that are parallel to each other are called bases. So there's a base, here's a base. Now I can turn this whole picture on its side, so they don't have to be on the top and bottom, but they have to be the two parallel sides. Okay. The other two sides are called legs. Okay. And then there's also a name for there's angle pairs. So if I look at this angle and this angle, those are both attached to the same base. Okay, so we would call this a base angle pair, just because they're attached to the same base. Okay, and so hey, this and this, that would be another base angle pair, right? Because those two are attached to the base at the top. Okay, and that's going to become important a little later in the notes. Okay, but also I want to point out you can also have a trapezoid that looks a little weird, maybe something like this. Not exactly the trapezoid we get in our building blocks that we used to play with, but hey, if it's got one pair of parallel sides, that would qualify as a trapezoid. Okay, all right. So let's move to a coordinate grid. We're asked to show that ABCD, or I guess it would, yeah, ABCD is a trapezoid. All right, so I want to show that it has exactly one pair of parallel sides. Okay, so it seems like this is the good candidate, right? The top and the bottom look like they might be parallel. These definitely do not look parallel. So I could check I actually, if I really wanted to get technical, I really should check these slopes and show that they're not the same. But I can actually see that this is a positive slope because it's going uphill left to right, and this is a negative one because it's going downhill. So I know those aren't parallel. But if I had more time, I would show that those aren't parallel. I'm just going to show that these two are parallel. Okay, so I'm going to start with BC. Let's find the slope there using the slope formula. Here's the slope formula in case you forgot it. Okay, so I'm going to take my y's. I'll do 2 minus 3 for my y's and 3 minus 0 for my x's. And I get negative 1 over 3, so negative 1/3. So I'm expecting that, oops, that didn't print out right, but this is negative 2, negative 1 here. So I'm expecting to get the same thing with AD. So let's see what happens. So subtracting my y's, negative 3 minus negative 1, and 4 minus negative 2. So that would be negative 3 plus 1, and positive 4 plus 2 would be 6. And then if I reduce that, hey, negative 1/3 again. So look at that. I've shown that this is a trapezoid. And again, yeah, you could go the extra step and show the other two sides are not parallel. Okay. All right. So next up, we've got the trapezoid mid-segment theorem. So let's first talk about what a mid-segment is. A mid-segment of a trapezoid is very similar to a mid-segment of a triangle. And if you remember in a triangle, a mid-segment connects two midpoints. Same thing's going to happen here. So if point E is a midpoint of that side, and point F is a midpoint of this side, then that means that this is a mid-segment. Okay? So yeah, I should define this too. Connects it connects the midpoints actually of the legs of the non-parallel sides, right? Because my parallel sides are the bases. So it connects midpoints of legs of a trapezoid. Okay. All right. So what do we need to know about this midsegment? There's two things. First off, it's going to be parallel to the bases. So that same kind of thing happened with triangles, right? When we had, just a little side thing here, when we had this same situation in a triangle, that side ended up being parallel to the side that it wasn't touching, right? And the same thing happens here. So this is going to be parallel to the other two sides. So that's the first property. And the other property you might remember for a triangle, if you took this and doubled it, then you get the midsegment's going to be half the length of the side that it's parallel to. And that's not exactly true here. If you look at this, clearly this line is not half the length of this one. It's way more than half. It's almost as long as this one. But if you compare that mid-segment length to the length of both bases, it's in between, right? It's longer than the top, and it's shorter than the bottom, and it's actually exactly halfway between. So it's the average length of the two bases, okay? Average length of the bases, okay? All right, so with that in mind, let's move on to the next two examples on the next page. All right, so hey, looking at this, it's a little hard to see, but this is a midpoint because I've got congruent parts there. This is a midpoint, BQ and QC are congruent. And then, hey, this is a trapezoid because those are marked. So, hey, that's the midsegment of a trapezoid. So I know x is going to be half the length of the average of 7 and 13. So what I'm just thinking is, well, x will be equal to the average of 7 and 13. The way I'd find the average of 7 and 13 is add them together and divide by 2, right? So, if you had a quiz score of 7 and another quiz of 13, the average, add them together, divide by 2. So then I'll get 20 over 2, and that is 10. And 10 is exactly halfway between 7 and 13 on the number line. So, maybe you can average those in your head, and you don't need to write out 7 plus 13 divided by 2, and that's fine. But you'll sometimes encounter problems like this. It's a little bit harder to do your averaging just in your head. So you want to think about this in the same kind of way. Okay, again, this is the mid-segment of this trapezoid. So this time 12.1 is going to be the average of x and 17.8. Okay, so my mid-segment is the average of the two base lengths. The two base lengths are x and 17.8. So if I wanted to average x and 17.8, that's what I would do. Okay? All right. So I've got a different unknown, right? It's a little different when x isn't the midsegment, it's one of the bases. So solving this, number of things you can do. The first thing I would do if it were me, and it is me right now, is to just double the whole equation. I'm going to do that so that I clear the fraction, right? Because 2 over 2 just equals 1. So that will be gone. And now I'll have 14.2 equals x plus 17.8. And this is just much nicer to deal with. No more fractions. Then all I have to do is subtract 17.8 from both sides. What happened? Oh, this is 24.2, isn't it? There we go. I had myself confused for a second because I doubled 12.4 wrong. So that's 24.2. All right, so 24.2. And then I'm going to subtract 17.8 from that, and I'm going to get 6.4. Okay. All right, I caught myself making a mistake there because I knew that I couldn't have that side length be negative, and that was about to come out negative. But I caught it in time. Okay. All right, so next up, we've got something called an isosceles trapezoid, and this is just a trapezoid where the two legs are congruent. Remember, an isosceles triangle, two of the legs are congruent, and the same thing with an isosceles trapezoid. Okay, so just to do a little definition sketch here. Hey, there's my bases, and my two legs would be the non-parallel sides, and these are going to be congruent. Okay. All right. So there are some properties, some theorems that go with trapezoids, but these ones are only going to work with isosceles trapezoids. So heads up, these are only for isosceles trapezoids. So hey, that's what I have right here, right? An isosceles trapezoid. So the isosceles trapezoid base angles theorem says that the base angles are going to be congruent. So I'm thinking, where are the base angles? Well, these two would be attached to the same base, right? So that means, hey, those two are congruent, and then the two at the top. These two are going to be congruent. It's not that all four are congruent because, hey, that angle's acute and that one's obtuse. So the two acute angles are congruent, the two obtuse ones are congruent, okay? So in other words, the base angles are congruent. Okay. Another thing that's true is the converse. So this is the converse of what we just did. So all we have to do, well, it's not quite as simple as just flipping it around. It's almost like that. But if you have a trapezoid, so I have to know that I'm dealing with a trapezoid. And then if one of the base angles pairs are congruent, you could have both pairs, but really you can do this with just one pair. So if you have a trapezoid where just one of the base angle pairs are congruent, then it's going to be an isosceles trapezoid. Okay, so it's not quite just flipping around the picture. It's a trapezoid with one pair of congruent base angles. Okay, let's move on to the next one. There's one more theorem here for isosceles trapezoids. So if you have an isosceles trapezoid, well, this is about the diagonals. So let's sketch in the diagonals. Okay, oops. So it sure doesn't look like I have right angles. It doesn't look like they're perpendicular. It also doesn't look like they bisect each other because they don't do those things. But the two diagonals are congruent. So again, this only works. So let me put A, B, C, D around here. The two, this only works for isosceles trapezoids. In a non-isosceles trapezoid, the diagonals are not going to be congruent. But in this case, AC is going to be congruent to BD. So yeah, the diagonals are congruent. Okay. All right, so let's hit this next example. So now we're going to solve. So I'm looking, what do I've got here? I've got an isosceles trapezoid, so I can use all of those theorems. So there was one about the angles. The base angles are going to be congruent to each other. So hey, I know that this is true. I also know that this is true. Okay, so angle Z, or Z itself, is going to be 42. Okay, so that's nice. Got that down. But what about X and Y? I don't have a theorem for consecutive angles, but I don't need a theorem because I can go way back to, I think it was chapter 3. I've got these parallel lines. Think about those as your tracks, right? Got those tracks. And then if I use this as a transversal, I'm thinking about what kind of angle pair do I have there? Well, those would be consecutive interior angles when the tracks are parallel. Then those are going to be supplementary. You can see they're not congruent, right? One's acute, one clearly looks like it's obtuse. But I can say x plus 42 equals 180. And that means x is going to be 138. Okay, and I already know x and y are equal to each other. So that means those are both 138. And the angles are 138 degrees, but x itself is 138. So is y. All right, so that's trapezoids. Second part of the section is about kites. So what is a kite? A kite is a quadrilateral. Again, these are all quadrilaterals. Everything in the chapter is a quadrilateral, pretty much. This is a quadrilateral with two pairs of consecutive congruent sides. Okay, so a kite looks like a kite, like an old-fashioned kite, like something like this. Okay, so two pairs of consecutive congruent sides. So that means I'm going to have two short sides that are next to each other. So the two short sides are congruent, and then I have two long sides that are next to each other as well, and those are also congruent. That is a kite. Okay, so let's look at some theorems for kites. Okay, so if you've got a kite, then what do we know about the diagonals? Well, let's sketch them in first. Okay, do they appear to be congruent? I don't think so. I think I've got a short diagonal and a long one. And actually, you're going to always have a short and a long one on a kite. Do they bisect each other? Well, this one actually does get bisected. The shorter one gets bisected, but the longer one doesn't. It's cut into a short piece and a long piece, but they are perpendicular. Diagonals are always perpendicular for kites. Okay, there's the diagonal kites theorem. Okay, the kites opposite angles theorem. So, this doesn't, you might think, oh, the opposite angles are going to be congruent. And it's partially true, okay? So, one of the pairs of opposite angles is going to be congruent, okay? So if you connect the two, like a short piece and a long piece, where those meet up, and then do the same thing across from that, that pair is going to be congruent, okay? I'll color code this, but this pair, notice I'm putting 2 dashes here and 1, 2, 3 dashes there. That pair is going to be non-congruent. Okay, so this is a little complicated, but so this has one pair of opposite angles congruent. Okay, and it's going to be the angles included between the short and long sides. Okay, and then, so there's the other one. There's the two congruent ones that I'm pointing the arrows to. All right, so moving on to the next page. Okay, now these aren't official theorems, but they are properties that come in pretty handy. Okay, so if you cut a kite up in different ways, you get triangles. And some of those triangles are congruent, and that can be very useful, okay? So if you, I've got a long diagonal and a short one. If you just draw in the longer diagonal in any kite, that's going to happen when you connect, I've got where the two congruent sides meet over here, the two short sides, two long sides meet here. These two triangles are going to be congruent to each other. And actually, we could figure this out in an old school way because we could use the reflexive property of congruence. That's going to be congruent to itself. And then by SSS, those two triangles are congruent, right? So I'm going to say triangle ABC, that's the top triangle, is congruent to the bottom triangle, which would be ADC. Okay. All right, what if we draw in both diagonals? Well, let's do that. Okay, Now I've got 4 different triangles. Clearly, if you look at all 4 triangles, they're not congruent, right? Because we've got small triangles and big ones. But it turns out the 2 small ones are going to be congruent, and so are the 2 big ones, okay? So, you know, I already knew that these were perpendicular, right? So let's think about this. I could use reflexive property here. I'm just trying to show you why these would be congruent. And then if I look at this, hey, wait a second, HL, right? Because now I've got 2 right triangles where I have a leg and a hypotenuse, okay? So those 2 are going to be congruent. And in the same kind of way, I could say, well, hey, I've got a right angle here and a right angle there. I could use a reflexive property. And then I could say that these 2 by HL again would be congruent. Oh, I've got 2 dashes there and 2 dashes there, so I'm going to change that to 4 dashes in there and there. Just to show that that is not supposed to be congruent to that. But the 2 blue triangles are congruent and the 2 orange triangles are congruent. So the blue triangles, I'll call this A, well, I should have put, let's call this point E, okay, in the middle there. So I'll call this AEB, triangle AEB is going to be congruent to triangle AED. And then also, I'll call this BEC, the top orange triangle, and the bottom orange triangle can be DEC. Okay, so those properties come in pretty useful sometimes. So one of those times is on a problem like this. Okay, now there are some different ways that you can approach a problem like this. But what I like to do with a problem like this is kind of think of this as 2 triangles. Okay, so if I draw in, I'm just going to kind of sketch in my longer diagonal here. Okay, now I knew that those 2 triangles were congruent, so doesn't that mean that those 2 angles are congruent? Okay, so this is going to bisect. And same thing over here, though that angle and that angle are going to be congruent to each other. So that means this is going to be 40 degrees and 40 degrees. This will be 25 degrees and 25 degrees. Now that's only going to work with the longer diagonal, right? It doesn't work with the shorter one. If you think about like this bigger blue triangle and this bigger orange triangle, they wouldn't be congruent, okay? But it does work like this, and that's super useful because now all I have to do is take, say, this top triangle here, and I can solve for x really quickly, okay? So I can say, okay, x plus 40 degrees plus 20, well, I'll just say x plus 40 plus 25 is going to equal 180, triangle angle sum theorem, right? Combine those like terms. I'll subtract 65. Okay, and then, you know, I could do the same calculation with y, but it's the same numbers, right? X and y are going to be congruent to each other because I'd still have y plus 40 plus 25 equals 180. So both x and y are going to be 115, okay? So there's a whole lot of properties for all of these quadrilaterals, but that's how it is. So that's the end of the section, and I'll see you next time.